So we'll proceed now with our final morning presentation. It's going to be given by John Brew from Novo Nordisk Research Center here in Seattle. Title is Management and Integration of Diverse Data Types in Type 1 Diabetes Research. So John is at Novo Nordisk and has been for a number of years now, but we first met him 7 years ago maybe, and he was in the Developmental Cakes Lab at the University of Washington. He was dark for a little while during the job switch, and then we're delighted to be working with him again.
Thank you. We need to pop something up here. And all right, that looks better. Well, okay, so today I want to give a little bit of an introduction to the data infrastructure we've built that's centered around LabKey that manages our diverse data types in Type 1 diabetes research setting. And in particular, I want to cover some of our thought process and design considerations that went into defining our priorities and ultimately the systems and infrastructure that we went ahead and implemented. Okay, so first I just want to give a little bit of background about our group. Our research unit was just established a little under 2 years ago, and is headed by Dr. Matthias von Hereth, who's a pretty renowned Type 1 diabetes researcher. We're located here in Seattle at Novo Nordisk's Seattle Research Center, which is right across the street from Fred Hutch and UW in the bustling South Lake Union area. And we're a site that consists of about 20, or at least the Type 1 diabetes research unit consists of about 20 researchers in the group. And our mission really is to pursue a translational research approach to finding a cure for Type 1 diabetes. And an important note is that our primary focus isn't on finding new targets and on discovery necessarily, but it's really on optimizing known assets in a clinical setting. So a little bit about Type 1 diabetes, and I'll just fly through this pretty quick. But it's an autoimmune disorder where the body's immune system destroys insulin-producing beta cells and leads to lack of insulin regulation. So it's polygenic. There's over 50 sort of identified associated genes, but nothing, but no single genetic driver has yet been discovered. The cause or the trigger for disease is more or less, it's pretty uncertain. Genetics and environment definitely seem to have a combinatory effect. And much of our knowledge comes from our non-obese diabetic mouse models. So a brief overview of the human impact of this disease is there's approximately 80 cases, newly diagnosed patients in the U.S. every day. So it's a pretty, there's a lot of impact of this disease. It primarily affects children and young adults, but it's also growing among older populations, 20 to 30 and older. And 80% of the people with Type 1 diabetes have no family history. There doesn't seem to be any gender bias, and there's no known cure at this point. So luckily it is a manageable disease with insulin replacement therapy. It does, however, take daily injections, daily insulin injections, along with careful management of diet and activity control. And this, is especially challenging for juveniles to manage the disease. There are certainly some serious complications that exist that can lead to problems with, feet, eyes, kidneys, nervous system, circulatory system, and that sort of thing. So, since it is a manageable disease, it actually complicates finding treatments a little bit. Treatments like chronic immune suppression, have been shown to halt disease progression, but it leaves patients immunocompromised and is very rough on the kidneys. Some charts of that over there. So another complication is that at diagnosis, there is strong evidence that very few functioning beta cells remain in the pancreas, and there's a lot of CD8 positive T cells that persist there. So it's kind of all the evidence is pointing to it's a very difficult, if not impossible, disease to actually clear. So looking upstream to preventative therapies has its own issues, namely that the primary risk population are juveniles and young adults, and there's a lack of definitive biomarkers and susceptibility markers for this disease. So it's hard to sort of really identify at-risk patients. Add to that conducting clinical trials in juveniles and the areas that we're looking at are really preventative trial-wise, probably infants in the range of 6 months to a year old. So that's it's a very, if you don't have good markers, it's hard to sort of enroll the right types of patients and get a good clinical result. So we have a slightly different approach to this, to looking for therapeutics. Again, I mentioned that we're focused on antigenic therapies that have already been validated in concept, and so this means we're revisiting known therapeutics that we feel just haven't been fully explored in the clinic, or maybe need additional studies and additional patient stratifications to hopefully find some good effects. So we want to validate these assets with the best animal models and use these animal models and human longitudinal studies to springboard some better biomarker identification programs. We also want to look at biologics for local suppression of inflammation and investigate combining these biologics with antigenic therapies to have, I guess, a more effective combination type therapy. So let's get through this here. And so here's just a little four-square summary of our approach. So we have 4 cornerstones. We have the biomarker kind of discovery. We have development of large animal models for tolerance validation. We have a careful stepwise clinical strategy to really focus on proof of concept and small-scale trials. And we also want to work closely with our key stakeholders from an early stage, and this includes bringing together key opinion leaders, clinicians, and researchers to fully explore and maximize therapeutic effects. So translating those high-level sort of science goals into a strategy for systems and infrastructure is kind of the fun part, at least of my job. We'll get to some of the considerations and challenges of this definition in a minute, but thinking from a high level, I just want to walk through how these large aspirations translate into systems for definition. So for biomarkers, it's definitely very sample-centric and a lot of material. So we need systems to manage both animal and clinical samples, the data from all the different biomarker assays that they're talking about doing, and I'll talk a little bit about details of some of those assays a little bit later. But we need to really sort of integrate all that assay information into some sort of cohesive set of data and information. And we also need systems for analytics, statistics, and visualization so that we have a chance of finding any meaningful signal in all that data. So for the animal studies, there's the issue of really the care and colony management. We have a lot of regulations, both internal and external oversight and regulations from the U.S., from where our parent company is in Denmark. We have to meet those regulations as well as some of the European Union regulations. So there's a lot of reporting that needs to go on. So we need good systems that allow us to document and meet all our requirements, certainly the standard of care for the animals, and take care of those reporting concerns. We need systems to help manage our observational studies, biological samples, and we also need to be able to manage assays performed on these samples, along with pathology data and other ancillary data. And of course, it goes without saying that we need good analytics and visualization systems to help interpret all this data. For proof of concept trials, again, many of the same systems and considerations for animal studies apply, but with the additional scrutiny of dealing with human samples. And certainly, again, we have to straddle this line between European, Danish, and U.S. regulations. So there's a lot more overhead to deal with that. So we need to make sure that our systems are suitable for use in a clinical setting. Lastly, we have collaboration. This means we really need systems to allow us to share data internally around the globe with all of our research sites and collaborators, and externally with some of our partners and people who are working with us on a lot of our studies. So we need good visualization and summarization capabilities so that our staff don't have to spend a lot of time putting together reports and collecting data for summary views. In the end, however, we need all these components tied together in one form or another, ideally as seamlessly as possible. So, knowing what types of systems and infrastructure we need to support, at least for the scientific aspirations, is kind of a good start. But there is additional considerations that weigh pretty heavily on our choice of systems and infrastructure, which I'll try to just highlight briefly. First, we were very fortunate, or I guess you could say unfortunate, that we didn't have, or that we had pretty much a clean slate to work with when we opened our site. We're a new outpost, about 5,000 miles from our R&D center. There wasn't any other groups in the company that were formally researching type 1 diabetes, so we kind of didn't have any people to ask questions and help us a lot along the way. And there's not a lot of translatable central systems or systems at the corporate level to really help us work with the types of data and the types of experiments and studies that we're going to be engaging in. So we pretty much had to, we had the opportunity to start from ground zero, so it was interesting. Usability for me is very key, more so since we have a fairly, even though it's a small site of only about 20, we have a fairly diverse user base, and everyone who's at the site is going to be directly involved in interacting with the system. So it was important that we had to have a very usable system and had to be functional and user-friendly. So we also have to have the ability to demonstrate value to users. I think that's very critical, especially for a new implementation. Is you want people to be able to see that there's tangible benefit and tangible value for them following a specific process or using any specific system to record and manage their data. Process and workflow centrality are really important. I'm a big proponent of good process, rigid process and workflow. But you want to really have, you need to be able to have some flexibility in that framework as well. The way that the world, there's day-to-day variations and things that people do, and there's always going to be exceptions. And unless you have systems that allow you to flexibly handle and manage those exceptions, you can get clogged up and can really sort of block the flow of information and the flow of data going in. So that's really kind of important. From a systems integration perspective, data mobility is really a critical requirement. And I'm talking about sort of data interoperability between systems. When you're looking at integrating or building systems of multiple hodgepodge of components, you either need to have extremely good open APIs and mature APIs to allow these data systems to talk together, or open access to the underlying data stores. And it's an absolute requirement, and it's something that can't be compromised on if you're going to have any success integrating different systems. So Along these same lines, though, is data management. And having a clear focus on data management from a top-down perspective has a lot of benefits. It helps to define what is important to the people involved. And so, if you can define, where the data points are and where they need help and how they work, it brings a lot of clarity, and it helps bring a lot of clarity to the needs and the systems that you need and the processes that you need to automate and to take care of. And so this, certainly ultimately leads to better definition of data tasks, which I think has a lot of benefit. So let's see here. So I certainly don't need to talk too much about evaluation or what systems we chose, since I think all kind of realize the punchline is LabKey Server is kind of central to the infrastructure that we have. But I do want to talk about how or some of the key features that sort of led us to LabKey and that the system has that we find absolutely invaluable. So, core to our site is we really kind of needed a system that allowed us to manage sort of day-to-day activity of our research and our studies and our experiments. And LabKey and its study capabilities really fit the bill quite well and give us a lot of flexibility and power to manage our studies and our day-to-day activities. The flexibility of LabKey's database, I think, is very, very important. And its ability to perform data aggregation so that we can do some cross-study comparisons was very, very key features. We have some the different data types. We have a lot of observational plate-based assays, and some cytometry, and a few different types of high-throughput data that we're looking on getting integrated. And certainly, the flexibility of LabKey to manage any generic plate-based assay and some very specific assays was a big driver. And it's customization, the ability to create reports easily, and it's data-centric views, tables, and queries were really big drivers. So, let's give a little bit about a little strange graphic with all the components. Running through this a little bit. So, again, some of the big drivers that I was talking about earlier are the colony management. We really needed a good animal colony management system and sample management system to be integrated with LabKey. It does an inherently very good job of importing and managing all the assay data. We've just started investigating. We actually have FlowJo Enterprise that we hope is going to help us with some of our standardizing some of our flow cytometry processing. And we're in the process of figuring out what level of integration we're going to have with that in LabKey. So it's a little bit to be determined, but I think it's going to allow us to do a lot of standardization and a lot of template-driven analysis. So that'll be a big benefit for our group. On the analysis side, again, it's the flexibility of being able to shape data for export to other specific analysis tools, be it tools like Prism or Spotfire or IOSD is one of the ones that we're looking at and using a lot lately, is very nice. It's so easy to do that, and we also have the ability to take the summary results from specific analyses, screenshots or data tables, and bring them back into LabKey and get them associated with the right studies and information. And certainly, we have a lot of reporting to do, regulatory, and because we're a large pharma company, we have to keep good track of our experiments and our progress. And LabKey makes it easy for us to get information out of those systems.
So the EasyCall software, what does it do? Or how do you export the data from LabKey? What data is
I'll get to that one. Oops, I thought that was next, but I'll get to that in a couple of slides. So we love the reporting capabilities, and one of the good things about setting up some of these things is you set up a report, or you set up a view once, and then you can sort of clone that across a bunch of different studies or experiments. So it's really sort of repeatable over lots of different areas, which is quite nice. So getting into some of the specifics, so our sample and freezer management system, we chose a tool called Freezer Pro. And Freezer Pro is a freezer management, sample management system that was developed by Ruro Incorporated out of Frederick, Maryland, I believe. So not too far from the NIH. It's a web-based freezer management system. It's fairly simple and fairly lightweight, but it also is very customizable and very flexible, and it has a good permission model, and it certainly is HIPAA compliant. So it had a lot of features that we want. We didn't need a real heavyweight system. We just needed to keep some of the basics about our samples and their location. And integrating that with LabKey, we were able to utilize. It has a fairly mature API with that system, and so we were able to. LabKey was able to develop for us a custom integration piece that used that API to allow us to bring in the sample and the sample processing type information that was recorded in Freezer Pro into LabKey studies, and automatically populates a specimen repository for a particular study. As those samples sort of show up in the Freezer Pro system, they have an association back to a specific participant in a study. So it's a pretty easy thing to set up. I think you just go to each study and that you want integrated and register the Freezer Pro API URL, I believe, and then this automatic association happens. So it's great as at least for our mice, as samples are collected, processed, and stored and registered in our sample system, they're automatically imported into the study where those animals are belong to. For colony management, we use another Ruro product called EasyCall. Again, it has a lot of the same attributes as the freezer system. There's a similar look and feel. It's another web-based animal colony management system, actually specific for mice. It has some good features, customizable alerts and reporting that our vivarium staff were really looking for, and iPad support, things like that. The integration with LabKey was a little bit different on this one. This had a very immature API. I think we were the first customer actually to try to use it, and it didn't really work well, but that's okay. One of the important things is it had we had open access to the database, so we could access the underlying data store, which allowed us to use the LabKey ETL functionality to set up the container really in LabKey that was continuously updating. So as updates happen in the colony system, LabKey captures that and puts it in a central container, which then we can access from individual studies to get the demographic information for all of our animals in the studies where they're needed. And that's really accomplished by writing specific queries to the information you want. And basically, we take most of the demographic information. I think that's a little bit abbreviated. But we take almost all the information, demographic type information about the animals from the colony management system via a query to the specific study. And then we use query snapshots in the studies themselves to make an actual demographic study data set that is updated sort of as information is changing in the mouse colony, but it is also a usable, queryable demographic data set inside the study. So it's quite nice and it's been very, very useful for us. So for analytics and visualization, we really take advantage of LabKey's ability to easily generate custom views and queries and format data in a way that's easy to import into the main systems that our scientists use to look at data. And one of the main systems that everybody uses is GraphPad Prism. It's very Excel-like, but it does have a couple of quirks with the way they stack some of the headers. But it's certainly easy to recapitulate that in LabKey. We use Spotfire and IOSD a lot, and those tools, especially IOSD, it likes its data sort of with a lot of columns, so it wants to try to capture as much information as it can about data to try to distinguish things a little bit better. So, but LabKey's been very flexible with helping us get this data formatted the way that we want for the tools that we have. So moving on to the built-in integration or built-in visualization tools, they've been really useful for us. And I have a few examples right here. This first two, this is sort of a pseudo heat map, I guess I call it, table. That severity of disease is really sort of color-coded, and the more severe, the darker the red I think we get. And our scientists really like setting up these types of views so they can quickly go through their experiments and their studies and have a good overview of how they're progressing and what's happening with their animals. Again, the built-in time charting that LabKey has come a long way in a couple of years, and in the last couple of years, and is very useful. I think this shows another similar chart to this heat map table, but in a more graphical plot format. So it's a different view of the same type of information that people can find useful. We have that flexibility to use what people like to see. The R integration that's built into LabKey has also been really powerful. It's nice to be able to quickly write scripts, do some analysis, and get some visualization out inside the system, in real time. So that's been a very useful feature. So I want to step up a level from specific integration details to more of a systems view and look at how we manage complex animal studies. So the main types of animal studies we typically run are prevention and intervention studies with around 100 animals and 30 to 35 week time frames. And we end up collecting thousands of data points during the course of these studies. And there's a lot of different users that interact or that are really sort of participating in the studies. We have things from the animal caretakers who mostly interact at the colony level, to the researchers and the scientists who are actually performing the data or the studies and collecting data during the course of the studies, and people running assays, running histology, and certainly looking at the data. So we end up, LabKey has to perform a lot of functions and pull a lot of data in from a lot of sources to keep these things running well. And I went through and want to talk about that. We utilize LabKey's study module to help us orchestrate and manage all this activity, and it really gives us a lot of power and ability to do day-to-day management. And we have LabKey's helped us develop custom work logs and templates that people use to figure out specific tasks. I mean, when experiments are ongoing, there's multiple people every day who are working with different subsets of animals for treatment and for observations, and it's important that everybody knows exactly what they're supposed to be doing on any particular day, and trying to help ensure that we don't have any overlap or miscommunication or things that are getting tasks that are not getting done in the study. So it's been a very powerful tool to help with that. And Tom Hudson will be talking about that tomorrow in a little bit more detail at the LabKey workshop. Let's see. So our longitudinal biomarker studies are are something that we're just really kind of getting started on. We've got some proof of concept animal models and human studies of at-risk patients ongoing right now, but it's still early days. Again, our vision for how we're going to set this up and manage this is again using LabKey study. We need this tight integration with the sample management system. We need to be able to import and associate all of our assay data, and being able to format, export, and sort of have some interaction with the analysis tools that people are going to use to look at all this biomarker data is going to be really important. So I think lastly, really, one of the primary drivers from day one for data systems was really the ability to aggregate and mash up data and run data mashups for a number of different reasons. For therapeutic comparative analysis, cross-study controls, cross-species biomarker correlation. There was a lot of drivers to this. And LabKey has been very good and has been very useful for helping us do these things. One of the examples I have, this chart, is from our historical colony incidence data. And the way we do this is every study that has untreated animals, they manage how they do that. There's a little bit of variability in there, but we have a central container that's always looking out and queries that go out to these studies to pull curated data really into this master set so we can keep track of these larger colony level trends and information. So it's been very powerful. So to wrap up, I'd just like to summarize some of the key points that led us to choose the data management systems we did. Having a clean slate to work with certainly was a nice luxury, but more importantly was having a top-down focus on data and systems. System flexibility and having that openness, either good APIs or open data sources, I think is really key to building an integrated infrastructure. And another big factor is developing clear data management plans. Like I said before, I think this really drives clarity and focus on specific tasks, which make the adoption and use of systems a lot cleaner. And always remember your mission. I think our mission is pretty clear. We're really focused on trying to prevent diabetes, type 1 diabetes. So with that, I just have a few acknowledgments. The LabKey people in particular, Britt and Avital have been absolutely great to work with and have done a great job of supporting us and helping us identify the components that we need developed that's specific for our work and getting that done. John Wesley and Dave Rodriguez have been really instrumental in helping me get things defined and getting these systems built. And everybody, all the people mentioned here, have really made major contributions to the effort of getting our systems up and running. And I think we've been fairly successful to date. We have good adoption with all the people who are involved, use the system well, and we've been doing a good job, I think, of capturing nearly everything, especially recently, studies and experiments in our LabKey infrastructure. So, thank you. Any questions?
Just one quick one. When you're integrating with Spotfire, do you use point Spotfire in your lab, use the tables or whatever, or are you actually trying to leverage the API?
We haven't leveraged the API yet. We usually just have the data formatted in a view, and then either pull that out and drop that into Spotfire. I think is what most people do at this point in time. Yeah. All right, thank you.
Great. Thanks very much, John. And I know there's some other groups here that are interested in, say, Freezer Pro or some of the other integrations that you've taken on. So hopefully, find a chance to talk today or tomorrow.